Good morning, Mr. Tucker.
Good morning. Good morning. How's it going?
Good. How are you doing?
I'm all right. Got a little headache, but I'm good. I'll be all right, man.
We were
Appreciate
hanging in there for you, I'm sure.
you. uh, Good morning, everyone. Good morning, everyone. Hope everybody's doing all right. Let's see. All right, trying to get everybody in here. All right, so guess we'll go ahead and get started. Anybody have any questions or concerns about anything before we get rolling? Everybody good? Everybody straight? Okay, cool. Let's go ahead and get to the notes. So we did 1.2 last class. And today we will be looking at 1.3. And I'm pretty sure it's everyone's favorite topic, which is word problems. So models and applications 1.3. So we have a 5-step strategy. Of course, you want to read the word problem. I always want to make sure you read it, make sure you understand what's going on in it, read it as many times as it takes. Because nobody knows how many times it took for you to read it. So feel free to read as many times it takes for you to get a full understanding of what's going on. Steps two and three, I kind of put asterisks beside because that's where a lot of people, if they're gonna get, I won't say caught up or hung up, but it's in those 2 steps. You want to write, in this case, you want to write each unknown in terms. Oh, no. I'll answer you in a second. We want to write each unknown in terms of the one variable. In other words, if you have more than one unknown, what you don't want to do is write, the first one X, call the other one Y, and call the other one Z, because the more variables you introduce, the more equations you'll need to be able to solve. And then you'll need a system of equations instead of just one equation. So we want to, in all the problems that you get in this section, every unknown that you have, you will be able to write it in terms of one variable. And you see what I mean when we get in there. Then you write an equation, and the equation will be based on the words that you received in the problem. Then from there, you'll solve it, and then you'll check, make sure you've actually answered the question. So you had a classmate that asked, make sure I got your question right. As far as homework, if you didn't finish 1.2, will it affect your grade? No, just want to make sure everybody's clear on that. When we do our homeworks or when we do a section, a lecture, you don't have to finish it by next class. What's going to happen is when we get closer to closing out chapter 1, I'll put a due date out there, and that'll be the due date for all of chapter 1's content. So right now you're fine. The fact that you got started is a good, it means you're in a good place. So keep on working. And what you don't want to do is wait until I put a due date out there to get started. So like I said, getting started now, that means you're in a good place. Once again, you do not have to finish homework assignments by the next class period. You can do that if you like, but you don't have to. All right. Very good. Can I scroll up? All right, so looking at our first example, and I'll give you a chance to write this down, but I'll read it first. The average yearly salary of a man with a, I try to shorthand some of this because I know it can get a little wordy. A man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. The average, and I left out average, that's why I had to put it in there in red. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree by $45,000. Combined, they earn $214,000. Find the yearly salary of each. Like I said, I give you a chance to write that down for those who are going to write the whole thing. All right, so we have a couple of unknowns here. Remember, the first step when it comes to word problems, you want to read it. So we've already read it. And so I got it down here. I was going to erase it, but let me erase some of this stuff. I'll just leave it. I'll just leave it right now. So in the red, step 2, it's right here. We have 3 unknowns. We have a man with an associate's degree, a man with a bachelor's degree, and a man with a master's degree. So we want to write an algebraic expression for each unknown that we have. So if you go back to the word problem, if you notice that the man with the bachelor's degree is described in terms of the guy with the associates. And then you see that the man with the master's is also described in terms of the guy with the associates. So what we can do is let the guy with the associates be called X, and then write the other ones in terms of X. So the man with the bachelor exceeds that of a man with the associates by 25,000. So if you exceed somebody by 25,000, that means that they have their salary, and then when you add 25 to it, that would be my salary. So that's why the bachelor's is X plus 25. And then the guy with the master's exceeds the guy with the associates with about 45. So that's X plus 45. All right, so before we go to the third step, is everybody okay with this right here and how we established X plus 25, X plus 45? All right. So third step, you want to write an equation based on keywords that you see in the problem. So the keyword here is combined. In other words, if you add them together, they earn $214,000. So that's what we did right here to green. And I'll just put the parentheses there just to signify what, came from what. So you have X plus 25 plus X plus 45. Those are your 3 representations of your salaries. Adding them together gives you 214. All right. So now step 4 is to solve. So once again, I put those grouping symbols there. You didn't have to, but there's nothing separating them once you take them off. All you do is combine your like terms. So X plus X plus X is 3X. 25 plus 45 is 70. So you have 3X plus 70 equal to 217. Then you subtract 70 from both sides. That's 3X equal to 144. Divide by 3, X is equal to 48. All right. Any problems? Any problems with that? So now once you get X equal to 48, you do have to go back and make sure you actually answer the question. So now here it says, find the salary of each. Find the salary of each. And so 48 is not good enough. They want the salary of each person. So what you do is you take 48, go back and plug it in for X in your algebraic representation for each. So 48 is the man with the associates. 48 plus 25 gives you 73. That's the man with the bachelor's. And then 48 plus 45 is 93. That would be the man with the master's. And you can check that by adding all 3 together, and that should give you 214. Because remember, adding them together gives you 214. All right. Questions on anything I've said on this problem? Should we okay? All right. Can I scroll up? As always, if I scroll up before you're done copying, feel free to let me know, whether it be through chat or unmuting. All right, so this next one, your local computer store is having a sale on cameras after a 40% price reduction. You purchased a camera for $276. What was the camera's price before the price reduction? So once again, I'll give you a few seconds, few minutes to go and write that down. All right, so we have a sale that's going on. Whether you've done retail or not, there's always a thought process that goes into a sale. And that's right, what I have right here in the red boxes. You have your original price minus the price reduction, and that gives you the sale price. All right. So in other words, as far as our equation is concerned, I need a representation for each one of those three pieces. Right. What was that? Okay, there we go. So we need a representation for each one of those three pieces. Now, the one that they give us straight up is the sale price, which is $276. Okay, I want to erase it. So it's 276. So we throw that in there. And then the original price should be easy to guess. That's what we're trying to find out. So we call that X. Now, the part that we need to be careful on is this piece right here, the price reduction. What a lot of people make a mistake is that they'll put 0.4 right there as your price reduction, or they will apply the 40% to the sales price and put that, just weird things that could happen. And I can understand each one of the thought processes. But the way you get this is to recognize that first we have a 40% price reduction, and you got to convert it to a decimal first. That's why we have 0.40. Now, don't forget, whenever you're dealing with percentages, very rarely does it stand alone. That only happens if you just calculating percentages. Percentages never stand alone. You're always doing a percentage of something, and of mathematically means multiplication. So nothing existed. When you look at this process right here, nothing existed except the original price. So it's not like you could do the price reduction of the sale price, or the price reduction can't stand alone. So you had to do your original price and do 40% of the original price. So that's why we have 0.40 times X. So always make sure you're careful when you're doing these sale problems, that that price reduction is based on what the original price was, because you're doing a price reduction of the original price. All right. So everybody okay with this setup? Just make sure we're okay. Hopefully that made sense. All right. So now we can find our, do our calculation. We go ahead and solve. So be careful here. A lot of people make a mistake on this part too. Now, the next thing you would do is combine your like terms. But don't forget there's a 1 sitting in front of this X. So that's 1 minus 0.4, which gives us 0.6. And I always have somebody to ask me, well, how? Because if forget the decimal stuff. There you go, right there. If you do 1.0 minus 0.4, you get 0.6. So yeah, that's that old arithmetic stuff y'all probably haven't seen in a while. Outside of that, you just throw it in the calculator, right? So so that 1 minus the 0.4 gives you 0.6. And then from there, 0.6x equal to 276. So divide by 0.6, and that will give you 460. And remember, X represents our original price, and that's what we were looking for. What was the camera's price before the reduction? So we don't have to do anything after that. All right. Any problems, any questions? Or look at another one.
Mr. Tucker,
Mm-hmm.
how did you know to do, like to put an X after the point 40?
So because the 40%, your percentages don't stand alone. You're always doing a percentage of something. So, and you have to multiply, in other words, you have to multiply your percentage by something. So you couldn't put just 40 here because that percentage does not stand alone. So you say, well, what were you taking 40% of? What, and so it was the original price because that was the only thing that was there before any of this occurred. So
Okay.
yeah, so that's why you have to do that. Your percentage wouldn't stand alone. It has to be applied to something or being multiplied to something.
Okay. Thank you.
Mhm. All right. Anything else? Anybody else before we go to the next one? All right. So this one, your grandmother needs help. She has $50,000 to invest. Part of this is to be invested in non-insured bonds, paying 15% annual interest. The rest of this money is to be invested in a government-insured COD, paying 7% annual interest. She needs $6,000 in extra income from the investments. How much should be placed in each? All right. Once again, give you a second to write that down. All right. So she has $50,000 altogether, and she wants to put part in an account that has 15% annual interest. Then she want to put part of it in an account that has 7% annual interest. The reason why she wants to split her money, who knows? But she doesn't know how much she want to put in which. It's not like there's a percentage. There's not, and you can't assume it's half. So you can't just split it up, 25,000 in one, 25,000 in the other. Because what dictates how much she puts in each is the fact that she needs $6,000. So whenever you have a situation like this, what you would do is, well, first, before we look at the red, let's go to the blue. We're talking about calculating simple interest. And I meant to put this first in the notes, but it's all good. So we're looking at earning interest off of an account. So we're looking at the simple interest formula. So that simple interest formula is I equal to PRT, where I is going to represent your interest earned. P is your principal, that's the deposit or the loan. R is your rate, that's going to be in decimal, and then time, T is time, that's going to be in years. So like I said, go ahead and copy that as a part of your notes first, then we'll go back to the red. All right, so we're going to lean on that. So we need to establish what is P, what is R, and what is T for both of these accounts. And then we'll move to the next piece as far as setting up your equation. All right. So now looking at both accounts, what we would do in order to have an algebraic representation. Did I hear somebody unmute?
Um,
Mhm.
I equals interest what?
Interest earned.
Okay.
I can write that better. Yeah. Just curious, was it too small or because it was too sloppy?
Sloppy.
Okay.
Sorry.
No. I know I wrote it a little jacked up. So I was just curious. It's all good. All right. So we have these two accounts. You know, we're going back to the red. Now we have an account at 15%, an account at 7%. So now what dictates how we set up P is that, remember that she didn't know which she was going to put in which and how much she was going to put in which one. Okay, so you can call either one of them X, it doesn't matter. Once you do all the work, it'll end up giving you the same answers. But you call one of them X, and then you call the other one the total minus X. So whenever that you have a problem and they don't tell you or give you a hint as to how much you would split it up into, like they don't say half or they don't say 3/4 is in here, and you know, they don't give you any hint, you can always call one of them X, and then the other one would be the total minus X. So that means once I solve for X, I can plug in that value here and then get the rest of it. So that's how that will always work for you if you don't have a hint on how much should go into which one. All right, so your rate is 15%, so you convert that to 0.15. The second account, the rate is 7%, so that'd be 0.07. You know, you just move the decimal 2 places to the left. And then we're talking about in 1 year. So the time is 1 year for both accounts.
So question.
Mm-hmm.
So for the 15%, P equals X, but for the 7%, it's 50,000 minus X. So why is it you're subtracting X from 50,000 with 7%, but not from the 15%?
You could have done either one.
Okay.
If I decided to put X here, then this one would be 50,000 minus the X. It's just always whichever one you choose, the other one is going to be the total minus X. Yeah.
Thank you.
Not a problem. Any other questions before we go to the next step in the process? Make sure we're okay. Still see writing, so I'll wait a second. All right, so now we have an algebraic representation for the unknown pieces. Now we want to set up our equation. So thought process here, we have a total amount of interest that we want to earn. So we're going to take the interest earned from the 15%, add it to the interest earned at the 7%, and that will give our total interest that we're trying to earn. So that's the thought process of how we want this equation to look. Now the total interest, we already said is 6,000. And then the interest earned in the 15% account, PRT, we just take an X times 0.15 times 1. That will be 0.15X. Same thought process, PRT, but remember P for the 7% account was 50,000 minus X. Then R is 0.07. And then that's 1 for T. And if you want to simplify that, you can go ahead and distribute that 0.07 into the parentheses, and that gives us 3,500 minus 0.07X. All right. So now if we add those together, so we have our total, which is 6,000 plus the 0.15x plus the 3,500 minus 0.07x. So I didn't need these parentheses here, but I just put them just to signify, the pieces. Any questions before we start moving forward? Make sure we okay. All right, so once you're here, you can go ahead and combine your like terms. We have 0.15x minus 0.07x. That gives us 0.08x. And we still have 3,500. Then from there, we subtract 3,500. And that will give us 2,500 equal to 0.08x. And then divide by the 0.08. And that gives us 31,250 for x. All right. So before we make sure we've answered the whole question, any problem with how we got the x? Okay. So 31,250, don't forget, represented x, which was our amount deposited at 15%. But then we need to figure out how much we deposited at 7%. So we take that 31,250, subtract it from 50,000, and that'll give us 18,750. And that will be our answer. All right, two answers. So the way it worked, remember I told you it didn't matter whether you use X for the one account, 50,000 minus X the other, or if you flipped it. So let's say if you had said 7% was X, and then 15% was 50,000 minus X. What you'd have done after you'd done your work, you would have came down and got 18,750, and then you subtracted from 50,000, then you would have had that answer. So you would have got the same answers regardless, just you would have got them in reverse order. All right. Questions before we look at another one. Now, keep in mind, you may not have any questions now. Questions may not come up until you actually get in there and start doing them on your own. And always remember, when it comes to word problems, if you need help, you cannot be like, hey, Mr. Tucker, I had a problem on this word problem. I'm like, all right. So then I ask you, which one was it? And you're like, oh man, I don't remember. And just like, I can't help you like that, because when it comes to word problems, I can pull out 5 word problems and still not address the issue that you had with the word problem that you were actually dealing with. So always remember, if you have a problem with the word problem that you want me to, try to walk you through, write it down, take a picture, do something of that nature. And so that I can, know what type of problem you're dealing with, and we can handle that one accordingly. So always make sure you notate that. All right, did I unmute? Yeah, unmute.
What was the actual question for the problem? I didn't finish writing it down.
Oh, okay. Well, you could have
Okay.
slowed me up. Yeah. Tell me right here.
Okay, I'm good. Thank you.
Oh, that's all you needed?
Yeah.
Oh, okay. All right. Anybody else before we look at another one? Anybody else? All right. Here we're looking at the length of an American football field. It's 200 feet more than the width. If the perimeter of the field is 1,040 feet, what are the dimensions? All right, so we're looking at the perimeter. Now, if we're talking about the perimeter of a football field, here's the formula for the perimeter of a rectangle. Remember, football field is rectangular in shape. So the perimeter formula for a rectangular shape is P equal to 2L plus 2W. So that means we need an algebraic representation for the length and the width. Remember, what we do not want to do is call one X and the other one Y. So we need to figure out a way to write each one of them in terms of one variable. So when we look at the description of the length, it says that the football field is 200 feet more than the width. So what we would do is we'll call the width X and then call the length X plus 200. All right. Make sure we're okay with that. We call 1X, which is the width, and the length, which is going to be longer than the width, X plus 200. Okay. The perimeter is 1,040 feet. So we have our three pieces right there for the formula. X plus 200, then 1,040 feet. And then we go ahead and plug them into the formula. And that's what I did right here. So where P was, I put 1040. Where L is, I put X plus 200. Then I just put X in where W is. Everybody okay? All right, so now you can go ahead and solve. Distribute 2, that's 2X plus 400. And then it's plus 2X. Combine your like terms, 2X and 2X gives you 4X. And so we'll be looking at 1040 equal to 4X plus 400. Then we'll subtract 400 from both sides. Then you're left with 640 equal to 4X. Then divide by 4. And X is equal to 160. Once you get your X, remember we wanted the dimensions, not just one part of your dimensional setup. So X is equal to 160. So that's your W, your width. Then if you add 200 to that, that'll be your length. So that'd be 360. So these would be your answers right here. All right, questions. All right, everybody good? Can I scroll up? All right, so the next type of exercise that they have in this section is solving for a specified variable. Going back to word problems before we get there, always make sure, like I say, you try these things out. Don't want to wait too long because we just tried some skills that you may not have used in a while or may not have used, period. So you want to try these things out before you get too far away from the lecture, so you can see if there's some things that you need to ask about. And every day is opportunity for questions. So make sure if you do try something and you get stuck on it, feel free to bring it up. We can always attack it before we close out. Also, email. And so just want to make sure you guys are good with that. So we're solving for a specified variable. Your goal is to get that variable by itself. They will let you know. They'll give you a problem that has more than one or two unknowns. So you're not going to get a solid answer. Like we got x equal to 160. You're not going to get that. You will have your variable equal to whatever expression that is left on the other side. So your goal is just to get that variable by itself. Now, also keep in mind that every variable that you see represents a number. So you're going to treat them the way you would treat your numbers. So here we have P equal to 2L plus 2W. That's our parameter formula that we just finished using. I'm going to solve for L. That means we're going to get L by itself. So if I had this type of setup right here, 7 equal to 2L plus 5, my first move to make would be to subtract 5 from both sides. So I can treat these letters the same way. So I have P equal to 2L plus 2W. And what I'm going to do is move this 2W by subtracting 2W from both sides. All right. So that will leave me with P minus 2W equal to 2L. Now, don't forget they are not like terms. So there's nothing you can do with the P minus 2W. It's just going to be P minus 2W. All right. So then from there, you divide both sides by 2 to get the 2 off of L. And this is your answer. Now, it's something that we can do with that going forward or moving one more step. And we're going to talk about that in a second, but I just want to make sure that everybody's okay getting right here. All right, everybody okay? So now I want to make sure we're okay that with the temptation of canceling out that 2 and make sure we don't do that incorrectly. So a lot of times when people see these 2s, they want to cancel them out, and then go on to the next thing. So if you do want to reduce further, I'm going to show you the right way and the wrong way of dealing with it. Understand you do not have to reduce any further with this because, well, I'll show you. So the incorrect way of reducing is to cancel out the 2s, and then you're sitting with P minus W. So you cannot just cancel out those 2s that way because of that minus sign that's sitting in between your 2 terms. So P minus W will be the wrong way of doing this. So now the correct way is recognizing that this 2 is in the denominator and it has to go to each term in your numerator. And so if you do that, that's going to be P over 2 minus 2W over 2. Now you can cancel out the 2s, but you still have a 2 that's under the P because that couldn't reduce. So you have P over 2 minus W. Okay, so if you wanted to go that next step, that's how you would do it, by taking the 2 into each numerator. Now, the reason why you don't have to is because this 2 does not fully cancel out. Now, if there was a number sitting in front of P that allowed that 2 to cancel out, you are expected to do that. And we'll talk about that in a second over there in the green to the left. But I just want to make sure everybody had a chance to copy down the incorrect way and the correct way of reducing this expression. Once again, because the 2 could not divide evenly into both terms, you could leave it like this answer right here. But you cannot do this. You cannot just cancel out the 2 and leave you with P minus W. All right. So Situation in which you have to reduce is over here in the green. So once again, I wrote up there a random example because I didn't want anybody to confuse, the scenario with the actual problem. This is not the same problem. I'm just saying if there was a 4 in front of that P, then you would have to reduce it. Because notice now, if you take the 2 into each numerator, the 2 can divide evenly into each part. 4P over 2, and then 2W over 2 will leave you at 2P minus W, and that would be your most simplified answer. So once again, if that number in the denominator can go into each term in your numerator, you are expected to reduce that. All right. Any questions before we look at another one? Okay, next one's A equal to P plus PRT, and we want to solve it for P. So notice that P is in 2 different terms, and you want to solve for a single P. So the way we would handle that is by factoring P out of each term. In other words, pull P to the front, and then in the parentheses, what is left? So that'll be 1 plus RT. And remember, when it comes to factoring, if you were to multiply this back into the parentheses, you should get what you originally had. So P times 1 is P, and then P times RT is PRT. So. All right. So we have A equal to P times 1 plus RT. Remember, your goal is to get P by itself. So we divide both sides by 1 plus RT. So that whole quantity, we divide both sides by that whole quantity. And that's it. That's your answer. P is equal to A over 1 plus RT. This over here, just some random. I think I was just explaining to somebody factoring process. Let me erase that. Right. Any questions before we look at? I think we got at least one more. All right. So here, let me see. I think this is the last one. Yep. So here we have A equal to 2LW plus 2LH plus 2WH, and we want to solve for H.
What is this formula for? I've seen this before.
It is another way to calculate the area. I think it's surface area of a rectangle.
Or a square or something like that.
Yeah, but it's another way because you can find the area by that's just a regular area, L times W, but I believe this is the surface area.
Okay.
Yeah, surface area of a rectangle. Yeah. All right. So goal is to get H by itself. What we want to do is get all of our terms without H to one side of the equation and all of our terms with H on the same side of the equation. So these 2 terms have H in it. So we want to leave those on one side and we subtract 2LW to the other side. And that gives us A minus 2LW equal to 2LH plus 2WH. All right. So remember last problem, what we did when we had the multiple terms that had the variable that we want to solve for, we go ahead and factor that term or that variable out. So we factor H out of each term. That leaves us with 2L plus 2W in the parentheses. Now we'll divide both sides by this 2L plus 2W. And that's our answer. H is by itself on the right. And on the left, we have A minus 2LW over 2L plus 2W. All right. Any problems, any questions? All right. Let's see, that was it for that. Let's see. What was 1.4? 1.4 was, what time is it? Well, this is the first week. We don't necessarily have to use up all the time. So we can pause right here. And this is a good place to stop. This class gets out at 9:15, right? Yep. So we won't necessarily have to fill it the whole time. This is, like I said, this is the first week. So you have two solid sections under your belt. So you got some things that you can work on. Next class, we'll get into 1.4 and, just keep it rolling. Did anybody have any questions on anything before we close today?
We're meeting again on next Monday, yeah? Not Friday?
I said Friday?
No, I don't know why. I think one of my classes said Friday and I'm trying to figure out which one it is.
Oh, okay. Okay. Yeah. Yeah. We're just Monday, Wednesday.
Okay.
You had me confused when I said, hold on, did I just say Friday? But I might
Yeah,
have said
one of my
Friday.
classes on Monday, somebody said Friday and I couldn't remember who said it. So
Right. Look, with everything, I might have said, I told you I woke up with a headache this morning, so I might have said Friday. So yeah, I'm glad you said that though, because somebody else could have had that question as well. So yeah, we only meet Monday, Wednesdays. So yeah, just see you guys on Monday.
thank you.
Yeah, not a problem. So anybody else before we close? Everybody good? Everybody straight? All right, so try the stuff out, see if you get stuck. If you have any questions, always feel free to ask. Outside of that, you guys have a great weekend, be safe, and I'll see you on Monday.
Thank you,
Have a
Professor.
good weekend.
Thank you. Y'all take care.
Good.
Feel
Take
better.
care.
Have a nice one.
Thanks, you do the same. Bye.
And
Thank you.
Thank
Mr.
you.
Tucker,
Mhm.
you got my email about my work schedule. I might come and join you at 8 o'clock, but I must leave around 8:30. I need to go back to office at 9.
Okay.
So
Yeah, I didn't see that from you, but that that's fine. That's all good.
is that okay?
Mhm.
Okay.
Yeah, not a problem.
Thank you
All
so much.
Not a
Have
problem.
good
Take
day.
care.
Bye.